What I mean by that is that we don't always include the things that really didn't do anything. So, for instance, if we're talking about this equation right here, where we've got this nitrate that's on this side and on this side, and that didn't do anything, and this potassium that's on this side and on this side that didn't do anything, those are our spectator ions. And so we would cross them out, and they wouldn't be included in that net ionic equation. And so what I'm going to write down here is what that net ionic equation would look like. So we'd have our Pb2 plus aqueous plus our I minus, two of them, aqueous. And there should be two there. Going to our PbI2 solid. Okay. So when we come to this next slide, of course, there should be two. Yeah, there's two there. So then when we come over here and we're looking at that lead nitrate and potassium iodate, the net ionic equation for that is that Pb2 plus aqueous plus 2I minus aqueous goes to PbI2 solid. So it's only the ions that are part of that formation of the solid that we include as that net ionic equation. So if we know that the silver chloride is the solid of interest in our magnesium chloride plus silver nitrate equation, because remember when we talked about this, it was that silver chloride solid that we formed, right? So it's only going to be that silver ion, Ag, plus that chloride ion, Ag, third Cl, plus the AgCl solid. Now, I understand that when we did this equation over here, we had 2 Ag and we had 2 Cl to make AgCl, right? But we don't have to include that there were two of them, because that's part of the balancing that happened because of the counter ion. It is not necessary to do that in our net ionic equation because we only need one Ag plus and one Cl minus to make AgCl. So we don't need to include that here. It is perfectly fine to include just Ag plus and Cl minus to make AgCl. That's okay. Now, again, looking at the sodium chloride and the silver nitrate, we again made silver chloride, right? That was the same solid that we made for this one. And so the net ionic equation is exactly the same. It's still Ag plus aqueous plus Cl minus aqueous going to AgCl solid. And it doesn't matter that they occurred in a different order in this equation, that they were Cl here and silver here. It really doesn't matter. We don't have to write them in that order, okay? It is not a requirement. We can do it. It's absolutely fine if we do. But I have a preference for writing my cation first and my anion second. So I tend to write them in that order, okay? So it's entirely up to you how you choose to do it, right? And again, in this reaction here, excuse me, what we wrote was that we needed to have the formation of the Ba solid, because that was the solid that we formed, right? So we're actually going to be looking at going from the Ba2 plus to the Ba solid, because that's the reaction that we were actually interested in looking at, was taking us from the aqueous component to the solid component. Cool. And here, what we were looking at was the H plus aqueous plus the OH minus aqueous going to the H2O liquid. And while it didn't form a solid, it did change physical state. So that's the reaction that we're concerned about there. Okay, so anything that goes in through an interesting chemistry, i.e. it's changed physical states, that's what we're looking. All right. So questions, comments, problems on our net ionic equations. All right, so those are the three types of equations that we're talking about. We have our molecular, where we include everything as being a molecule. So everything appears together. It looks like it's a molecule. We have it, balanced based on charges so that they appear together. We have our ionic equation, where everything is broken up into ions. Okay, they appear as if they were, together, based on the and balanced as if they were in the same place. And then our net ionic equations, where we only include the things that are involved in the interesting chemistry. Okay, we remove all of our spectators. All right, so those are different types of equations. Okay, now we're going to do some equations practice. So I'm going to have you do the equations practice for the following equations. Some of these are precipitation reactions. One of these is not. So I'll have you do some practice for this. I'm going to come back and give you the answers. So I'll be back in a few minutes to walk you through this. I'm going to walk through the details of two of these, and then I'll just give you the answers for the other three. So take a few minutes and work with this, and I'll be back with you shortly. Thanks, guys. All right, guys. So we've come back, and we're going to be talking about copper 2 bromide. So remember that copper is Cu. I know his charge is 2 plus because that's what that 2 means. Bromide is Br minus. All right. So looking at that, I know that this is going to be Cu2 plus aqueous. I'm going to add to that. Didn't give myself enough space. Plus 2 Br minus, and that's aqueous. I'm going to react that with Ag plus, that's aqueous, and then acetate. And of course, just in case you don't remember, we've got our acetate ion, and I'm going to come up here to look at that table that I've got. Let me look at my acetate. And you see the acetate is CH3COO minus. CH3COO minus. That's aqueous. And that comes across and gives me some product to produce copper 2 acetate. So that's Cu2 plus aqueous, I think, plus my, sorry, CH3COO minus, and I'm going to need 2 of those. I need to put a 2 out there. Aqueous. I'll check that in just a minute. Plus, and so that's copper and acetate, and then I'm going to have my Ag plus aqueous plus Br minus aqueous, because it's 1 to 1 there. But that means I'm going to need 2 of those also. So then I'm going to have 2 Ag there and 2 Br there. So I need to check my solubilities for my copper bromide, or my copper acetate, and my silver bromide. So I need to come and check my rules and see what we got going on. So the first thing I'm going to look at is my copper 2 acetate. So I see acetate here, and it says all common compounds of acetate are soluble. So I'm not worried about that copper 2 acetate. That's fine. But I need to look at that silver, Ag plus, and that's what Br minus is. It says all common compounds of bromide, Br minus, except for Ag plus, are soluble. So that Ag plus is not. So instead of this being like I wrote it, that Ag plus and that Br minus should not be written as aqueous components. I need to erase this, and I need to write this as instead. I swear I just erased that. As 2AgEr solid. So that's my ionic equation for that. Now, if I wanted to write a molecular equation for this, and I'm just going to put it above, so molecular here, ionic here, and that's typically the way we write them is molecular, ionic, net ionic. So my molecular equation would be CuEr2, putting that back together, plus 2AgCH3COO going to CuCH3COO, and I needed 2 in front of that because there were 2 of them, plus 2AgBr solid. And this one should be aqueous, this one should be aqueous, and that one should be aqueous. And then, of course, if I want to write my net ionic, then this one would be, so my solid is here, 2Ag plus 2Br minus, both of which are AQ, going to 2AgBr solid. And of course, I don't necessarily have to put the 2's in front of that, but I can. It's perfectly fine. Okay, so that's the first one. So that's one of them. All right, let's scooch up a little bit. Let's talk about the second one. Now it says mercury 1 nitrate. Now mercury 1, mercury is, according to my happy little guy right here, I can look down here and I can see that I have this right here is Hg2 plus. That is actually mercury 1, okay? Because mercury 1 has a +1 charge. So if I have Hg2 plus, that's mercury 1, okay? So mercury 1 is Hg2 plus. If it was Hg2 plus, that'd be mercury 2. So it's a weird guy that we're talking about right there. And I know that that's his charge because I can see him right here. Right? So Hg2 plus, and then my nitrate is NO3 minus, and then my potassium iodide. So potassium is K plus, iodine is I minus, to give mercury 1 Hg2 plus, iodide I minus, and potassium nitrate, so K plus NO3 minus. And the reason I wrote it up there is because I knew that there were some solubility rules having to do with that. I didn't remember what they were, so I wanted to write them up there so that I could look down here. Now, mercury and nitrate, I know that nitrate is up here, and all common compounds of nitrate are soluble. So this first instance is soluble. But this second one, it says all common compounds of iodine are soluble except, and that's that Hg2 plus, and that one is not. So this guy right here, this thing is not soluble. So when that one is in my equation, that one's not going to be soluble. So let's write this out the way that it exists. So in my molecular equation, I have Hg2 NO3 2, because I've got to have 2 of the NO3 minus to go with the Hg2 plus. So this 2 stays. The 2 plus indicates I need 2 of the NO3 minuses. And that's aqueous. I add to that 2 Ki. So I know it needs 3 Ki, and I know I'm going to need 2 of them to balance that charge on the other side. And then I'm going to need, on the other side, I'm going to have Hg2 I2. Again, I need 2 I minus to go with the 2 plus. This is going to be a solid plus 2 KNO3. So I have 2 Ks, 2 Ks, 2 NO3s, 2 NO3s, 2 Is, 2 Is. And so I know that that is balanced the way it's supposed to be. And, oh, Lord, there you go. Sorry, too far. Yeah. Okay. And this is aqueous as well. This is aqueous. So that's my molecular equation. Now if I want to write it all out in my ions, I have Hg2, 2 plus, that is aqueous, plus 2 NO3 minus, again, this is aqueous, plus 2 K plus, aqueous, plus 2 I minus, again, this is aqueous, goes to Hg2, 2 plus, is, oh, wait, hold on. I didn't want to do that because that doesn't break up. So I don't want to show the charge there. Hg2, I2 solid plus 2K plus aqueous plus 2. And I'm actually going to move this down. Sorry, it's just not going to fit. Plus 2 NO3 minus aqueous. Okay. And then, of course, and that's my ionic. And my net ionic, barely going to fit. And that's my Hg2, 2 plus, aqueous, plus 2 I minus, aqueous, going to Hg2, I2, solid. Whew. Well, that was fun. Okay, so those are the 2 I decided to go through in detail. Now, I'm going to flip over and I'm going to give you some answers for the other 3. So this is barium hydroxide. It's H2SO4. Both of those are aqueous. Going to water as a liquid and BaSO4 as a solid. So Ba2 plus 2OH minus plus 2H plus 2SO4 2 minus plus 2H2O liquid plus BaSO4 solid. There are 2 net ionic equations for this. Ba2 plus 2SO4 2 minus going to BaSO4 solid. That's 1, so the formation is solid. Or the 2OH minus plus the 2H plus going to give 2H2O liquid. Either one of those is interesting chemistry. It depends on which perspective we want to focus on. That will determine which one we choose. Okay. The next equation, we have sodium sulfide Na2S aqueous plus 2 RbNO3, so rubidium nitrate. Aqueous going to 2 NaNO3, sodium nitrate, plus Rb2S, which is rubidium sulfide. Right, that gives me 2 Na plus 2 plus S 2 minus plus 2 Rb plus 2 NO3 minus, going to 2 Na plus 2 NO3 minus. Those are both soluble, plus 2 Rb plus S2 minus, because that's also soluble, which means that I have no solid which is formed, which means there's no reaction. Okay, that happens. Okay, just because I've written an equation like this does not mean anything actually occurs. So you may see these from time to time. The next one, again, we have 2 NaF, sodium fluoride, plus SrNO32, which is strontium nitrate, goes to 2 NaNO3, sodium nitrate, plus SrF2, so strontium fluoride. Again, that's 2 Na plus 2 F minus plus Sr2 plus 2 NO3 minus goes to 2 Na plus 2 NO3 minus, because both of those are still aqueous. I should say that this is aqueous. Plus Sr2 plus 2 F minus, both of which are still aqueous, which again means that there is no reaction. So again, nothing interesting happened here, no net ionic equation. So checking that solubility, all of those products were soluble. Okay? So that is what we have for our aqueous solutions there. Questions, comments, problem? Okay. I'm going to take a short break right here. I'm going to go ahead and stop this and set up a new video at this point, and I'll be back with you shortly. Thanks, guys.